All right, 7.2 is about scientific notation, which I'm assuming you've used some already, but we're just going to spend about a day talking about it here. So it's a shorthand way to write numbers using powers of 10. Things that are very big and things that are very small is when it comes in handy using scientific notation. So do you know there are 75,000 genes in each human cell and more than 50 trillion cells in our body? That means that there's 75,000 times 50 trillion. That would be a low estimate of the number of genes in your body. That would be really hard to write, right? We'd have lots of zeros. So in order to avoid that, we started using scientific notation. So exponents become very useful when writing numbers that are either really, really big or really small numbers close to zero. For instance, is there a simpler way of writing the number 143, 000,000,000 or 0.0000000067? So there is, let's take a look at some examples below, and we need to decide if what is and what is not scientific notation. So it says the ones on the left are in scientific notation. The ones on the right are not in scientific notation. I see lots of tens raised to the something, which we said they're in bases of 10. So I would guess that that would be one component. You need to have something raised or times 10 to the something. And you'll notice here we actually in scientific in scientific notation, we do use the time symbol as an X, which I always say don't use X anymore, but that's the only time that we do it as scientific notation. So if you look at these, 3.4 times 10 to the 5th is. 27 times 10 to the 4th is not. 7.04 times 10 to the 3rd is. 120 million is not. 1 times 10 to the 2nd is. 0.42 times 10 to the 6th is not. And you can keep reading them. But if you look, let's explain what happens. All of these, the number in front, which we're going to call A, and it says in scientific notation, A times 10 to the n. If you want it to be in scientific notation, A times 10 to the n, you have to have it where the A is greater than or equal to 1 and less than 10. Not less than or equal to, but less than 10. So if you look in the left column, 3.4, that's between 1 and 10. 7.04, that works. 1, it says it can be equal to 1, so that works. 6.023, that's in that range. 3.9, perfect. If you look at the not, 27, too big. We need to change it. So we could change it to 2.7. But if I moved that 1 to the, I made that smaller, I have to make my 10 to the 4th one bigger, so it'd be 10 to the 5th. So we can change them, but you'll notice all the ones on the not scientific, those numbers don't start with a something point something or something between a 1 and a 10, so that's a requirement. So let's look, is it written in scientific notation? First example, no, because it needs to be 2.3 times 10 to the something. This one we made this number bigger, so we have to make this number smaller. We have to do opposites to keep it the same. So this one, 3.4 times 10 to the 2nd. Yes, this one is. This one was not, by the way. No. Now it is. So we changed it. This one already is. 3.4 is bigger than or equal to 1 and less than 10. 9.3 times 100 to the 6th. That is not. Because we need 10 to the 6th, not 100 to the 6th. We need 10 to the n, not 100 to the n. That is why it's not. So on a calculator, you can actually enter scientific notation in. You can see, you can use a scientific calculator to work with numbers in scientific notation. The E, or the double E actually, it looks like button, which is a blue one of our buttons, on the calculator readout stands for exponential. So when we go to enter it, if you want to enter 20 to the 10th, we would enter 20, you know, just like we normally do. So enter 20. So 2, 0. Actually, we're going to put 20 in there. Enter 20. So we're going to type in 2, 0, and then the second button. And we're looking for the double E, which is right here on that key, because it's above, it's one of the blue ones. So second, we're going to hit the X to the -1, which actually gives you that double E. And when you do that, the readout is going to say, excuse me, 20E. And now you have to say to the 10th. So that is what you're going to type in on your calculator. And again, the circled spot is the button we're using. So, should have grabbed one of your calculators. So what do you get? 20 to the 10th, and it will give you it in scientific notation on your calculator too. So 20 to the 10th should be 1.024 times 10 to the 13th. So exactly on your calculator, again, it's going to give you a E. Let me just grab one of your calculators so I'm making sure I'm saying the right stuff because I have mine. Oh yeah, I don't know what I had entered into mine, so let's erase that last little bit. 20 to the 10th. I don't know how my calculator came up with 1.024 times 10 to the 13th, because that is so not right. 20 to the 10th. On your calculator, if you plug this in, it will say 2 times 10 to the 11th, which would make sense. 2, and it says on there actually times 10 to the 11th. And when you think about it, 20 to the 10th, we need to make this one smaller. So this has to get one larger. So it'd be 2.0 or 2.0, yeah, times 10 to the 11th. So enter 4 times 10 to the 6th. If you want to enter that into your calculator, you can hit 4, hit the second button again, and that's double E. And then you'd have hit 6, and you'd get it to enter out 4 with 6 zeros. 1, 2, 3, 4, 5, 6. So based on the examples below, when are negative exponents used and when are positive exponents used? So if you look at these numbers, 0.0004 is 4 times 10 to the negative 4th. 0.004, 4 times 10 to the negative 3rd. 0.04 is times 10 to the negative 2nd. 0.4 is 10 to the negative 1st. So you'll see all of these numbers are the negatives, and all of these numbers are the positives. So when do we use negative exponents? You should say when the number is less than 1. All those numbers, 0.004, 0.04, 0.4, those are all less than 1. And when do we use positive exponents? For numbers greater than 1. Now apply your definition by completing the chart below. This number is standard notation. So here's what I do. I count over 3, 6, 9, 12, 15, 18, 19, 20, 21. I have to go over 21, and I would get 3.78 times 10 to the 21st, because I go over 21 spots to get it to the 3.78 that I want it to be. This one I go over 3, 6, 7 spots, so it's 3.2 times 10 to the 7th. This one I go over 1, 2, 3 spots, 2 times 10 to the 3rd. This one I go 3, 6, 8, but I go that way, so they're negative. So it's 3.4 times 10 to the negative 8th. Remember, if we were trying to write numbers less than 1, we're going to have a negative exponent. So this is 3, 4, 5, 6. So 6.73 times 10 to the negative 6. This one we have to go over 1, 2, 3. So we'd get 5 times 10 to the negative 3rd. This one, we are doing the opposite. So we're going to write the number out. So it has a negative exponent. So I know it's going to be, I'm going to have a number less than 0, excuse me, less than 1. Here's moving it 1, 2, 3, 4. So 0, 0, 0 is my answer. 0.00023. The next one, we have a positive exponent, so I know it's going to be a big number. So I'm just going to take that 3, 7, 6, 5, 1, and I'm going to move it over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spots. So I just have to fill all these in with zeros. And that's my number. Let's see. 1, 2, 3, comma, 1, 2, 3, comma. So 37, 6, 5, 1, 0, 0, 0, 0, 0, 0. A huge number. This one to the negative 9th, so I know it's going to get smaller. I'm going to have numbers less than 1. So 9, 8, 6. I move this 1, 2, 3, 4, 5, 6, 7, 8, 9, and now that's my decimal over here, and I have to fill in all these zeros. And there is what we have. That's it for this section.